Okay, so question 13. Nice easy question about sample statistics. So we're given some information here. The heights of a sample of male students and female students in secondary school are summarised below. So this is the sample size that we've taken. These are the mean heights, and these are the standard deviations. So we want to determine the approximate 95% confidence interval for the population mean of the heights of the female students. Okay, so all we need to do, first things first, I'm going to state the important information. Now, we are looking at, hold on a second, let me bring back the question. So question 13 is what we're doing. Okay, so female students, meaning we're looking at this one and this one. And we want to determine a 95% confidence interval. Now, the first thing I'm going to do is go and grab my z-score because I know that I'm going to have to use my formula for this. So z is going to be equal to, now, I don't remember these, so I'm going to grab my calculator and I'm going to get it to do it for me. So, statistics is the one that we want to go into. Execute. Then we're going distribution, normal, and if we're looking for the z-score, we're going to use intra-n. Now, our tail needs to be central for z-scores. And the area we're looking for is the confidence interval that it's asked us for. So here it's asked us for 95, so 0.95. And we leave our standard deviation as 1 and our mean as 1. Okay, so our z-score is 1.9 and we'll round that to 6. So our z-score equals 1.96. The other things that are going into our formula here, if I state my formula for the confidence interval, that's going to be the mean minus z multiplied by our sample deviation over the square root of the number of people in the sample, and our mean plus our z-score for the sample over n. Okay, so next thing we can state, n, our sample size is 78. The mean that they've given us here is 167.4, so we're going to be using that one. And our standard deviation that's given to us here is our population standard deviation. So we're going to be looking for our sample deviation, which is calculated using central limit theory. So it'll be the deviation divided by square root of 78. Now, if you're in your exams and you're not 100% sure which one it is, make a statement about why you think it is. I would think that because this says the heights of a sample of male and female students in secondary school are summarised below, that you could say that this is from the sample. But, again, make a statement to justify why you've done what you've done. Okay, so now I've got everything. Now that the standard deviation is going to be 4.3. And now I'm ready to just chuck everything into my confidence interval formula. So 167.4 minus 1.96 multiplied by 4.3 over the square root of 78. That'll make up our lower portion. Then to do our upper portion, we're just going to chuck the same thing in, but we're going to change it to a plus. All right, so once I throw that into the calculator, I'll get the following answers of 166.45 and 169.35. Okay, so let's just summarize again what you've actually found. So you've determined the approximate 95% confidence interval for the population mean of the heights of female students. So you're 95% confident that the true mean height or the true population height is going to be somewhere between this one and this one. All right, it might be this, it might be slightly higher, it might be slightly less. We're 95% confident that the real population parameter lies between these two. Okay, now we can do part B. So the confidence interval that's stated here was calculated from the population mean of the heights of male students. So now we're looking at male students, not the females, which means our numbers are going to change to these. Okay, so the heights of male students. Determine the confidence level that was used to calculate this interval. So now we're doing the reverse. We're going to find our z-score and then we're going to work out the area. So give your answer correct to 0.1%. Okay, so I'm just going to scroll down a little bit and then I'm going to write down those numbers. So okay, so number in the sample, 62. The mean is going to be 176.3, and our standard deviation is going to be 5.1. Okay, so next thing we're going to do is we are going to calculate our confidence interval. Well, we're really just going to chuck it into the formula and work it out from there. So I know that I'm given these two here. If I choose the lower, it's going to go with the minus part. If I choose the upper, it's going to go with the plus part. Doesn't matter which one you choose. I'm going to do this one, which means I'm using the minus. So 175.377 is equal to, now it's normally equal to our mean. You're looking at the formula booklet. Our mean, 176.3 minus z, because that's the thing we're trying to find, over 5.1 all over the square root of 62. Okay, so now from this point, solve n. If you're allowed to use the calculator, use it as much as you can. So once you've got your solve n, all you need to do for that, go back to your regular run matrix, options, calc, solve n, chuck it in, 175.377 is equal to, shift, equal, 176.3 minus x, bracket, fraction inside of there, so 5.1 over square root of 62. That, close that bracket. Now, I always put comma x on the end. If your calculator has got something saved in there, it might give you a wrong answer just because you didn't put comma x on the end. So then we press execute, and we get the answer of 1.425. Okay, if I round it to 4 decimal places. So z is equal to 1.425. So I want to find the confidence level to go along with that. So now I'm going to go back to my calculator, and I'm going to do this in reverse. So if you think about this as the picture, z-scores talk about the central area. I want to know what the area is, because that's the probability or the confidence interval that's under the curve. I've got a lower, because the z-score represents that proportional, symmetrical either side. So the lower is going to be negative 1.425, and the upper is going to be positive 1.425, which will represent this point and this point on your score. So in order to find that, I'm going to go statistics, distribution, normal, inverse normal this time. Now, actually, sorry, we want the area, which means we're not going into that one. Distribution, normal, NCD. Now I can input my lower is negative 1.425. My upper is 1.425. I'm going to leave my standard deviation and my mean as they are. Press execute, and it tells me that the probability of that happening, we're going to go to 4 decimal places. So 0.8458. 0.8458. Or if I convert that to a percentage, that'll be 84.58%. Now, if I leave it like that, I'm missing a mark because I've ignored this part of the question. So it only wants 1 decimal in the percentage. That means I need to round this number. So that means that the confidence level is 84.6%. Okay, and that satisfies everything that we've been talking about.